So we started out today by getting these metals, and there are actually 4 different ones, but this is just showing you 3 of them so you get the idea. So each of these is labeled as being 1 mole. So we have 1 mole of metal B. Now that's not boron, but it's just saying this is some metal, and then 1 mole of metal C, some different metal, and 1 mole of metal D. So we ask a few questions. First of all, do these have the same weight? So we could put them on the scale, but that's not really necessary even. This one is very light, and then these are a little bit heavier, with this one being the heaviest. We could just kind of feel that, but you could put them on the scale and see. They don't have the same weight. We also asked, do they have the same size or the same volume? And you can quickly see that this one is a good bit larger. And while these are somewhat similar in size, probably not exact, but they're pretty close. But this one is different, yet they're all 1 mole. Right? Are they the same color? You can see pretty quickly that they're not the same color. So they're not all the same size, they don't have the same weight, they don't have the same color. So what does it mean if they're all 1 mole? So we discussed how that just means that they all have the exact same number of atoms inside them. So we can kind of go back to the chicken discussion, where we have the chicken egg and the quail egg. If you have a dozen chicken eggs and a dozen quail eggs, they're not going to be the same size. They're not going to weigh the same amount. They're not going to look the same. The dozen just tells us how many there are. So in this bar, there are 6.022 times 10 to the 23rd atoms of some type. And in this bar, there are that many atoms of a different type. And in this bar, there are that many atoms of a different type. So those different type atoms give rise to different masses and different volumes. Remember, atoms have different sizes, as well as different colors. Depending on the color actually comes from the electron arrangement and how it catches light. So we see here that the mole is referring to how many. The second question we ask is, okay, if this is 1 mole of metal B and C and D, how could I figure out what metal it is? All right, and so we came to the conclusion that we could weigh them. And the weight of this metal would tell me what metal it is, because the mass on the periodic table is for 1 mole. So for example, if I weigh this and it weighs about 27 grams, 1 mole of this is 27 grams, I can say this must be aluminum, because aluminum's mass on the periodic table is 27 grams. And that mass on the periodic table refers to 1 mole. All right, then we went into something a little bit more complex. We're looking at this container. This container says it has substance A, but it's not 1 mole. It's 0.15 moles. Okay, and then you can see what substance A looks like. So 0.15 moles of substance A in this container, and I've got to figure out what substance A is. Luckily, I have an empty container that can help me. All right. I also have a list of possible substances, which I'll show you in just a second. So I've got to figure out what substance is in this container based on the fact that there's 0.15 moles of it, and I can weigh it. All right. So I've already done the weighing part. I found that the filled container, this one right here, weighs 16.20 grams, and the empty one 7.46 grams. So I'm going to subtract those two to find the mass of the stuff inside, which is what I really care about. So 16.20 minus 7.46. So substance A in that container has a mass of 8.74 grams. Now that is for 0.15 moles of substance A. All right, and I'm trying to figure out what substance A is. So make sure you're following along with my train of thought here. In order to figure out what a substance is, you need to know its molar mass. Okay, because the molar mass can identify the substance. So here's my list of possible substances. I'm going to put it up here. Right, and then again, here's my containers. And here's the work I've done so far. Alright, so in order to figure out what substance this is, what I need to do is to figure out how much 1 mole of this would weigh. Because 1 mole, the weight of that is on the periodic table. Okay? The weight of 0.15 mole of something is not on the periodic table, but I can figure it out. So I'm going to set up a ratio. I've got 8.47 grams of this substance, and I have 0.15 mole of it. So my question is, how much would this substance weigh if I had 1 mole of it? Alright, so then I'm going to go cross, so 0.15x equals 8.47 times 1 is, of course, 8.47. And I'm going to divide by 0.15. So x equals 56.47 grams. Alright, so that's how much 1 mole of this would weigh. I got to figure out which of these it is. Remember, 1 mole of something, its mass is found on the periodic table. So all I have to do is go through and see which of these has a mass closest to 56.47 grams from the periodic table. Alright, so I'm going to start right here. Calcium has a mass of 40 grams. Then carbon would be 12 times 4 carbons, plus hydrogen times 6, plus oxygen times 6. That turns out to be 190. Okay, so I can say for sure it's not that one. Calcium oxide. Calcium is 40 and oxygen is 16.01. Actually, calcium is 40.08 plus 16.01. And that is 56.09 grams. That's for the calcium oxide. That sounds like it might be pretty close to that. Remember, we're doing lab with our scales that aren't necessarily the most excellent. So that might be it. Let's go through the others and make sure there's nothing else closer. So for potassium, 39.1 times 2 plus 32 for sulfur plus 16 times 4. That one turns out to be 96, so it's not that one. The next one, 23 for sodium plus 12 times 2 plus 1 times 3 plus 16 times 2. That one turns out to be 82, so that's not as close either. Moving over here, 23 times 2 plus 12 plus 16 times 3. That turns out to be 106, so not that one. And then 23 plus 35.45. That one turns out to be 58.45, so that's pretty close, but not as close as 56.09. And then finally the zinc, 65.38 plus 16. That one turns out to be 81. So the closest one here is calcium oxide. So I can say of those choices, this substance in this container is most likely calcium oxide. So again, we took our mass from the scale after we subtracted and put it over the amount, 0.15 mole. And then we said, okay, how much would it be if it was 1 mole? Because 1 mole is what the periodic table shows us. Then I looked up all of these on the periodic table to see which one was closest to my X value. All right, hope that makes sense. Hope that helps. Good luck on the quiz tomorrow.